Okay, this chapter is called sampling distributions, and sampling distributions are the backbone of statistics. So let's start with a simple example of what a sampling distribution is. So suppose we put our two classes together and I take a sample of size 10 and I get your average height for that sample. And then I take a new sample of size 10 and I get the average height for that sample. And then I take another sample of size 10 and I get the average height for that sample. And I keep repeating that over and over and over again. And then I take all of those averages from each of those samples and then I plot them together in a histogram and look at the shape that that histogram makes. That's what we're interested in when we look at sampling distributions. Now, fortunately, we don't actually have to do this by hand. We can look at simulating this. So we're going to go ahead and do that with a computer simulation. There's a link at the bottom of this PowerPoint, but I'm going to go ahead and head over there now. Okay, so here's where that link goes, and we're going to simulate a sampling distribution here. So what this is our population distribution is normally distributed. That's what you see at the top of the screen. And what we're going to do is we're going to take a sample of size 5. So I'm going to click this animated button, and let's take a sample of size 5, and it'll find the average. And what it does is it drops that blue block that tells you what the average is. So I'm going to repeat that. So it'll pull a new sample of size 5, we'll get a new average. Okay, and I can keep repeating that. Okay. All right. Okay, and I can speed this up by having it do 5 sets of those at a time so we can kind of see where this is going. Okay, let's be a little more efficient. Let's take 10,000 sets of these at a time. All right, and so you can see that this creates a normally distributed sampling distribution. Okay, and we know that normal distributions, we spent an entire chapter on that in chapter 3. We have great ways of finding probabilities with normal distributions. Okay, so this sampling distribution came out normal, which is a great thing. Let's see if that pattern holds. So let's try a different distribution. Let's see what happens if we start with a uniform distribution. So we'll pull a sample of 5 again. There goes our 5 blocks, and we have an average. We'll do that again. We'll keep doing that. Okay, so let's speed it up here. Let's drop 10,000 samples of size 10. There we go. Okay, so it turns out if we do this with a uniform distribution, we also end up with a normal sampling distribution. All right, let's see what else we have. Let's try a skewed distribution. So we'll pull a sample of size 5. So there goes our 5 blocks, and the blue one represents the average of those 5. We'll do that again. Okay, so we'll go by 5s here, see it slowly build up. Okay, so we're kind of seeing some variation there. All right, so let's drop about 10,000 samples. We kind of keep playing with that. And sure enough, before too long, this is starting to look pretty normally distributed. Okay, so it doesn't matter what our starting population looks like. If we're doing a sampling distribution where we're looking at all of the various samples we can get of the same size, and we plot all of those averages, we're going to get something that looks normally distributed. All right, so let's go back and look a little bit more about defining our sampling distributions. All right, so let's define this. What is the difference between a population distribution and a sampling distribution? So a population distribution is going to describe the individuals in your population. Okay, so we're looking at an individual measurement for each and every single individual, and that's how we're going to create our histogram. Our sampling distribution is where we're going to take a statistic from our sample, and that's what we're going to be interested in plotting. So maybe we're interested in how our sample mean varies across all the different samples that we have. Okay, so our sampling distribution is concerned about how our statistic, our sampling mean, is going to vary across our samples. Where a population distribution is how each individual person varies. Okay, so strictly speaking, the sampling distribution is the ideal pattern that we would get if we looked at every single possible sample of size 10 from our class, or whatever sample size you're using. Okay, so let's look at our classwork and make sure that we really feel comfortable and understand this idea. So we have an example about sleep. So it says the 2012 American Time Use Survey contains data on how many minutes of sleep per night each of 12,443 survey participants estimated they got. The times follow the normal distribution with a mean of 528.8 minutes and a standard deviation of 137.2 minutes. A simple random sample of 100 of the participants has a mean of 509.23 minutes. Then they took a second simple random sample of size 100 and had a slightly different mean, so 530.32 minutes. So they did lots and lots of simple random samples of size 100, and after they did those lots of times, they found that the sample mean followed a normal distribution with a mean of 528.8 minutes and a standard deviation of 13.72 minutes. Okay, so we have some questions to work on, so let's take a look at that classwork. Okay, so the first question is, what is the population? So our population, we were pulling these samples from the survey, so our population is the survey group. So that is the 12,443 sleep survey participants. Okay, and then it says, what values does the population distribution describe? It describes how the individual sleep times vary. Okay, and then what type of distribution is this? So it says that it is normally distributed up here, so it says the times are normally distributed. Remember, we mark a normal distribution with a capital letter N. And then we have some parentheses, and the first number we list is the mean. So it tells us the mean is 528.8, and that there's a mean of 137.2. Okay, so any normal distribution is labeled this way. This says it's normal distribution with a mean 528.8 and a standard deviation 137.2. All right, question 4 says, what values does the sampling distribution of x-bar describe? So the sampling distribution is going to describe how the samples, or how the sample mean from samples of size 100 varies. Okay, so instead of how the individual sleep times vary, we're looking at how the sample mean of sleep from samples of size 100 vary. And the problem tells us that this is also normally distributed, which is what matches from what we saw in the simulation, that we got those normal distributions. And it also has a mean of 528.8, but our standard deviation is 13.72. Okay, so that's what we're looking at there for this problem. And we're going to look at how you can calculate that so you don't have to deal with simulation or read it from that problem.